So this lesson is about 3.3, solve quadratic equations. So first of all, quadratic equation is still the same as we introduced before. Has the form ax squared plus bx plus c equals 0. So x is a variable, a, b, c are constants. To understand how the completing a square works, so it is actually based on this kind of strategy. So if you have a simple equation x squared equals 4, it's still considered a uh, quadratic equation because you have the exponent of the x equals 2. So for this kind of question, obviously it's pretty easy. Just take square roots on both sides, and then don't forget x equals positive negative square root 4. Okay, so then x equals positive negative 2. And if you plug in back to the original equation to verify, it should work. Okay, now let's look at the first case. Although the original format is a x squared plus bx plus c, and we could have a simplified form, and in this case actually like x squared equals 4, so we do have the c, right? If we move over here, it becomes x squared minus 4 equals 0. So but we don't have the b, and also the a equals 1, so it's become very simplified form. And then let's look at it here, the first case here. So this is the form that we have the b equals 0. So obviously it's a little bit complicated than the original one. So what we need to do is we move the c minus c on both sides. So you get a c to the other side, becomes negative c. And then you divide by a on both sides, so you get ax squared equals negative c over a. And then this one it looks like a negative, but it may not be because it depends on what the c and a is. So don't worry, we just take square roots on this, so we should get positive negative, and then square root negative c over a. And of course, if you know a and c, and you may end up getting negative number inside of the square root, and then there's no solution, no real solution. Okay, look at one example here. So all this example I explain in very detail, showing that what you're supposed to do on both sides of the equation, and then what would you get. Okay, so the first step is try to move everything, all the constant, to the other side, so you don't have another x. So pretty easy. So plus 7, so and then 7 plus 8 here, you get a 15 here, and then divide by 3, and obviously you got x squared equals 5. Then take square root on both sides, so x equals positive negative 5. Now since the 5 is positive, so we do have two roots, positive 5 and or negative 5. So if you plug in, you can check, and that should be correct. Okay, second case is we have the a equals 1, so everything else is still the same. So in this case, we're gonna move the constant over the other side, it becomes negative c. And then this is the key step. So if you have x squared plus b x plus, and then we add a one term. So add a one term, this term is actually half of this coefficient, which is b, divide, so b over 2, so that's half of it. And then don't forget, you need to square this term. Okay, so you added the same term on the other side as well. So in this case, and then this side is going to become the x plus b over 2 squared. So that's actually the rule you have to know about the square complete. So basically, whenever you have a trinomial, if you don't have any number in front of x squared, so the third number, it should be half of the b and then squared. Okay, so every time you form this kind of thing, we just make up like this, right? We make it up like this, and then we should be able to form the squared. If you can verify by expand this one, you should get back to this. Okay. So here you go. We got a other side. We just simplify b squared over 4 minus c, and then we are ready to take square roots on both sides. Right? Take square root on both sides. So x plus b over 2 plus minus whatever inside on the right side. Put it into the radical sign, and then just move minus b over 2 on both sides, so you get this over the other side, it becomes a negative. So that would be the root. Okay, of course it's still possible, there's no real solution if whatever inside the square root, the radical sign is negative. So okay, so look at another example. Example 2, solve this equation. You can see the a here equals 1. So again, pretty straightforward. So you do on both sides, do something on both sides, and then you get the equation. Okay, so first of all, try to move the constant to the other side. So we plus 3 on both sides. And then you add one term, which is half of the b, so the 4, half of the 4, so I use 4 divided by 2, then square. So that's actually just 4. Okay, see, I add a 4, and on the other side you add a 4 as well, add on to the 3, you get a 7. So, and then just simplify and complete the square, so this one becomes x plus 2. So the 2 is actually half of this, right? So it's actually square root of this, or square root of the 4. So x plus 2 squared equals 7. And take square root on both sides. So you get x plus 2 equals positive negative square root 7. And then minus 2 on both sides, you get this. Okay, so that should be 2 roots of this equation. Okay, finally, we get the third case when we have a, b, c all there. Okay, so the a is not equals 1 anymore. Okay, but as first step, actually we try to make the a become the coefficient before x squared equals 1. So very simple, we just divide by a on two sides of the equation. So then each term on the left side has to be divided by a. So when you divide by a on this, so the a is gone. So here it becomes b over a, here it becomes c over a, and equals 0 divided by a, of course, still be 0. Then very similar, we just move the c over a to the other sides. And then we just add half of this. Now be careful, b over a divided by 2 it equals b over 2a. Okay, and then we square it. Don't forget it. Half of this, then square. So you put it here. Of course, you put the same thing on the other side. And then this one will become becomes a square, like x plus b over 2a. So the b over 2a is just the square root of this, positive square root of this. And then on the other side, if you just put them together, right? So you can just you can see. So the way I did is, because if you square this, you got a b squared over 4a squared. So I need to change this. I change this 4a squared. So basically, I multiply the 4a on denominator, and you have to multiply 4a on top as well. And it's 4ca, and later on I change it to 4ac right here. So yeah, and yeah, it becomes here 4ac, right? So it's just simplified, and you got a square on the left side and got everything here, and then take a square root on both sides. So very similar. So this one should equal positive negative of the square root, and then just subtract the b over 2a. So it moved to the other side. So x equals this. This one actually later on you can see this is actually the formula for a quadratic equation, a general formula. You can put them together. It becomes negative b plus minus square root b squared minus 4ac divided by 2a, right? So I just skipped the last step. Okay, now look at the example 3. So this is an example that we have a, b, c all there, very similar. So I just want to skip all this part, and you can see by yourself. Okay. Okay, so finally I explain one of the question in the book. It's number 14 on page 210. So this is considered a difficult question. It involved variable. even the constant is unknown. So consider this quadratic equation: x squared plus bx plus 10 equals 0, and where b is a constant. So determine the possible values of b so that this equation does not have a solution. Now, we already explained that in some case we don't have solution, right? Whenever something appear in the radical sign is negative, so then we won't have a real solution. And then we just try to do the same thing, completing the square. So follow exactly the same strategy, move the constant over the other side, so it becomes negative 10. Then you add half of the b, then square it on both sides, and then the left side it becomes x plus b over 2 squared, so that's a completed square. On the other side it's just whatever you put it together. And then you can see if we don't even need to do the square root, because this side equals to something squared, so it has to be greater than 0. And if we do have this side, the right side, b squared over 4 minus 10 is negative, right? And then the equation has no real solution, right? So you can't have something squared equals something negative. Right? It's impossible. And then we just focus on this, try to solve this inequality. So we'll move the 10 plus 10 on both sides, so 10 moves to the other side. And then now here you need to be very careful. So if you take a square root on this one, and then you could have this, you should have this. The square root should be the b over 2 absolute value sign, and then less than the. Okay, this is not equation, inequality. You have to be very careful. So only when the absolute value of b over 2 less than 10, and then when you square it, right? When you square it, so it should be less than 10, right? Okay, and then it depends on what's the b. If the b is negative, and then this one has to be greater than negative square root 10, right? And then when b is positive, and this one has to be smaller than the square root of 10. And then based on this 2, you have to multiply 2 on both sides, so the b becomes more than, either be more than negative 10, or b is smaller than more than negative 2 square root 10, or b is smaller than 2 square root 10. So then you put these two together, so the b must be between these two numbers, so that when you square the b, it has to be smaller than actually 40, right? 40, and that should be true, right? So actually in the first place we can multiply 4 on both sides, change this one into b squared. Yeah, we can do this way. So it's actually equivalent to b squared less than 40, right? So in the first place, if we do this, and then this one becomes, let's just change everything. So this one should be b squared less than 40, and then if you take square root, you should get a b less than square root 40. Okay, and then if you this one, square root 40, you can take the 4 out, so it becomes 2 square root 2, right? And then we can change it a little bit here, so you should get b is more than negative 2 square root 10, or b is smaller than 2 square root 10. Yeah, that looks better. And then these two combine, you get this. Okay.